Hello everybody. So in the previous video, we went through all the types of supports available. And in this particular video, we'll be going to types of loading system. We have different types of loads or loading system available. So in all the previous modules, you went through one of the types of loading system, which was point load. You have the types of supports of different types of support reactions. Now let us go through different types of loading systems. So basically, we have three types of loading system. The first type is point load. And the second type is uniformly distributed load. We call it as UDL. It's uniformly distributed load. UDL is uniformly distributed load. And the third type is UVL, uniformly varying load. So the first type is point load, second type is uniformly distributed load, and the third type is uniformly varying load. These are the three types of loading systems available. So let us start with the first one. The first type is point load. So you know what point load is. You went through point load in the previous modules. In second and first module, you had point loads. Point loads are nothing but they are the forces or loads acting at a particular point. Or it concentrates on a particular point. It's also called as concentrated load. So it can be either vertical, horizontal, or inclined. You went through this type in the previous modules, in second and first module. So all the force into its horizontal and vertical components. So if the loading system is in a point load system, in this particular system, it's always easy to analyze. You have two more types of loading system. The first, out of these two, the first type is uniformly distributed load. So this is all about point load. Let us concentrate on uniformly distributed load, which is a new concept for all of you. So listen to me very carefully. The second type is uniformly distributed load. As the name suggests, the load is uniformly distributed. Whereas in point load, the load concentrates on a particular point. In the case of point load, but here in the case of uniformly distributed load, the load is being uniformly distributed. Throughout the cross section of beam or throughout a particular span. L. Let this point be A and let this point be B. Just follow. So here, this is uniformly distributed load. So load should be uniformly distributed throughout the cross section. We have considered the cross section or the span as L. So load should be uniformly distributed in this way, indicated in this way. Load is uniformly distributed. It's not concentrating on a particular. It doesn't concentrate on a particular point. It doesn't act on a particular point. Instead, it uniformly distributes throughout the given span. So distribution is shown in this way. And here, the rate of load distribution is given. You will not be given with the exact magnitude of load. Exact magnitude cannot be given because the load is uniformly distributed throughout the span, is it not? So that's why you'll be given with the rate of load distribution. Let me consider it as W, Newton per meter. Newton per meter indicates the rate of load distribution. Because load is uniform, this is the rate of load distribution, rate of the uniform distribution of load. Now, this is how the uniformly distributed loads will be given. So if UDL is given, what are we supposed to do is the question. So if UDL is given to you, you have to convert UDL into a point load system is the question now. Let us convert it. I'll help you to convert. B of length L. Now, so this is the rate of load distribution. Is shown here. So you have to convert the UDL into a point load. In order to analyze it properly or to make the analysis easy, you have to convert UDL into a point load. So this is how you convert UDL into a point load. Now, the point load, what you convert from UDL, point load what you convert from UDL should act exactly at the center of the span. So this should be L by 2 load. And the magnitude of point load what you convert. Magnitude of point load. This is the rate of load distribution. W is the rate of load distribution. So magnitude of this point load will be W into L. Will be W into L. W into L. So how it is W into L? W is in Newton per meter. Is it Newton per meter? And L is in meters. So this gets cancelled and finally you will get the load in terms of Newton. This is the magnitude of point load. This is the magnitude of point load. This is how you convert. This is the magnitude of point load. What you convert from UDL. So when UDL is given in the problem, if UDL, uniformly distributed load, is given in the problem, you have to convert UDL into a point load. So this is how you convert UDL into a point load. So if UDL is given, the point load which is being converted from UDL will act exactly at the center of the span. Will act exactly at the center of the span. So this will be L by 2 and L by 2. And the magnitude of point load will be rate of load distribution, W into the span length. L will be the magnitude of point load. So if UDL is given, you have to convert UDL into a point load. You have to convert UDL into a point load. So this is all about uniformly distributed load. This is all about uniformly distributed load. Now let us go through uniformly varying load, the last type. Uniformly varying load. Let me consider another beam cross section, AB again. So here load is uniformly distributed, but here the load is uniformly varying. It varies uniformly throughout the cross section and it will always be indicated in this way. Rate of load distribution. This is a beam of span length L. So W will be the rate of load distribution, W Newton per meter. Here the load uniformly varies. It increases from point A to point B in a triangular pattern. It increases. Now, so if you load and if you have UVL, let us understand how to convert UVL into a point load. Let me consider the same cross section again, AB of span length L. Now here in UDL, the converted point load would act exactly at the center. Exactly at the center. But here it's not the case. It will not act exactly at the center. It will not act exactly at the center. It will be acting at a distance. If this is the 1/3 from base and 2/3 from apex. So if this is a triangle, I'll let you know what base and apex is. This will be the apex. This will be the apex and this will be the base. This will be the base. So this will be the apex and this will be the base. Now the point load which we get when we, so this is the apex and this is the base. So 1/3 of L from base and 2/3 of L from apex. So it acts exactly at the center, but here it is from it acts at a distance of 1/3 from the base and 2/3 from the apex. This is the point load, half into W into L, half into W into L. Here it is half into W into L. Half into W into L is the area of triangle, half into base into W into length or height. Yeah. Hope this is clear. This is how you convert all the loading systems into point load. So this is point load. Is point load acts or concentrates at a particular point. UDL is a type of loading system where load is uniformly distributed cross section. So if you have UDL where load is uniformly distributed, you have to convert it back to a point load, and this is how you convert back, and its magnitude will be the product of rate of load distribution and L straight away. So if you consider UVL, again you have to convert uniformly varying load into a point load as this is the apex and this is the base, and its magnitude will not be W into L, it will be half into W into L, half into W into L, and find UVL into a point load. This is the point load converted back from UVL, and this is the point load converted back from UDL. So finally, everything should be converted back to point load. Finally, everything should be converted back to point loads. So these are the three types of loading system.